Good afternoon. This is Ethan Sakaransky, meteorologist. Going to give a quick long-range forecast update today. And one of the big pattern drivers that's caught my attention lately has been the cooling of the sea surface temperature anomalies across the North Pacific. Taking a look at this map, the difference between Halloween and the 1st of September, there's been quite a bit of a drop-off in the anomalies extending from Kamchatka all the way east into the Bering Sea and Gulf of Alaska. And taking a look at the CDAS SST data, this is just another data set, but the trend is the same. Below normal anomalies emerging across the far northern Pacific, whereas across the subtropical Pacific from latitudes 20 to 40 north, the anomalies have been much above normal. And then the tropical Pacific can see this La Nina pattern in place. Right now, it looks like more of a basin-wide event or mixed event as opposed to being east-based or west-based. And then in the Indian Ocean, there's a negative Indian Ocean dipole phase, which is represented by these cold water across the western Indian Ocean and warm waters across the eastern Indian Ocean. On the NOAA Coral Reef Watch dataset, the trend is much the same, with cooling over the last 15 days across the Gulf of Alaska being clearly demonstrated and consistent with the other data that we've seen. Having a look at a time series of the sea surface temperature anomalies across the subpolar Pacific, so from latitudes 45 to 65 north, they've dropped by about 2 degrees Celsius from the beginning of September all the way to the beginning of November. And that's a pretty significant number. So what that tells me is that there must be something going on in the atmosphere that has led to this change in sea surface temperatures. There must be something causing it. And that's what I'll talk about in the next slide. And the average upper level pattern from September 1st to October 31st shows a strong trough centered over the East Siberian Sea into the Bering Sea with a belt of strong upper level winds towards the south. And that helped cause mixing of the surface layers of the North Pacific Ocean water, which contributed to cooling of those sea surface temperatures. Meanwhile, further to the south across the subtropics, the ridging that remained in place kept those sea surface temperatures from cooling down. With regard to the overall North American temperature pattern, much of the continent had a above normal month of October, and I would attribute at least a decent part of that to the fact that across the northern Pacific, there has not been any high pressure over Alaska, which, if it were in place, it would allow Arctic air to come down from northern Canada. But instead, that trough across Alaska and Siberia has prevented much of the cold air from coming down, and instead the air coming into North America has had more of a Pacific origin. And if we look at what the European seasonal model was forecasting back on September the 1st, for the months of September, October, and November, it had some trough here across the East Siberian Sea, but it was underestimated relative to what we saw, which was a very strong trough. And because of that, it missed out on the magnitude of the warmth that we saw across northern and central Canada. The CANSIPS model missed out on the trough across the East Siberian Sea, and as a result of that, it was outperformed by the European model during this time period. But if we look at what the forecast is from the European moving forward into winter, it has a reversal of the pattern to this ridging pattern that begins to evolve with air coming down from the Arctic into central North America. And so that's a pretty big change from the pattern we've seen so far this fall, which, kind of begs the question, is it going to be right? Is there going to be a change in that North Pacific pattern from a lot of low pressure to high pressure? Arguments in favor of that would be the La Nina in place. Generally, when you have a La Nina, it's more likely that you get ridging across the far North Pacific with, the type of pattern that you see on the European seasonal is more consistent as well with a lot of the analog years that I was looking at that are similar to this year in terms of overall pattern when we look at everything. So that would support this pattern. But what goes against it is what we've seen so far in September and October, which is a tendency for a lot of troughing extending all the way from Kamchatka east towards the Gulf of Alaska. And so until that pattern starts to change in a significant way, I'm still a bit skeptical about whether or not this pattern will evolve in a way that's sustained. Here's the first half of November, which looks similar to what we've seen so far in October, similar to what I was mentioning before, with a lot of this low pressure across the north. And taking a look at a broader look of the whole hemisphere, part of the reason that we're actually expected to see some cold air coming in towards the middle of November is via a different mechanism because of this blocking ridge that starts to appear across Greenland, which may be an equally important factor moving forward because the QBO this winter is in the easterly phase, which favors more blocking across the Arctic and Greenland. So that may be a predominant mode of bringing that Arctic air down into the east especially. But I am a little bit more skeptical about whether or not we see that happening in Alaska as well. And then looking at the European weeklies, this is week 1, much of the same. Here's week 2 on the European weeklies. Notice the blocking coming into Greenland. Week 3, still a lot of low pressure across the Bering Sea. Now, where we start to see the change is week 4, 5, and 6. So here's week 4. Notice the high pressure coming in now towards Alaska. Week 5, same thing. And week 6, same thing. This looks a lot like what we saw on the seasonal model for December through February. And this allows cold air to come into central North America and into the east. And this would be a cold pattern across areas that are often favored in a La Nina season. So that would be, Canadian prairies, northern plains of the United States, Midwest, Great Lakes, even parts of eastern Canada and interior Northeast as well. So this would be the type of pattern that would be conducive to cold and snow through December. But in order for that to happen, as I mentioned before, we'll need to see the changes actually being observed across Alaska as opposed to just being forecast, wanting to see those observations start to change as well. And then a big driver as well will be the MJO and the way that convection is occurring across the tropics. In September and October, much of that was focused towards phases 1 through 4, Indian Ocean and into the Indonesia. But now as we get into November and into December, it's starting to take a turn more into phases 7 and 8 potentially, which could lead towards a colder pattern. But there are some questions on whether or not it can get into phase 8 or whether it comes back and weakens into the middle circle. And looking at this diagram of the convection moving forward, the European model is favoring the convection coming in towards South America towards the end of November, which does favor more of a phase 8 configuration, which would support turn towards a colder pattern towards the middle and end of November, consistent with more blocking across the Arctic, Greenland blocking, and more of a colder pattern setting in. So that's going to be something that we're going to have to look out for as well. If you have any questions, please let me know. Thank you for listening. Bye for now.